Welcome to Bite-sized Data Science. Last time, we talked about how to view big data in the context of our data size and how we use the data. This time, we need to talk about how it is stored. In the context of data science, we usually think of data as being read-only. We get some data, do some transformations, and then the data is ready to use. If we get additional data, the additional records are appended to the existing files or tables. Updates can be more problematic since we then need to find and remove the old records. Using a read-only approach is not new. We also see it in data warehouses and data marts. What is the data we are storing? At a high level, we can divide it as structured, semi-structured, and unstructured data. What does that mean? When we talked about structured data, it refers to data that is divided in multiple columns. For example, we can have records that include fields like gender, estimated income, and age. Semi-structured data is often used in formats such as XML and JSON. In our example here, we see that this JSON document has a hierarchical structure where we have the top level, input field, that includes two other variables, fields and values. These variables then include a set of values. Since it has some structure to it, this document is machine readable. Obviously, it is also human readable. As the complexity of a JSON document increases, it becomes more difficult for humans to read them. The benefits of these types of documents is that they are self-described. This makes them more flexible since new fields can be added without necessarily break existing programs using them. Personally, I find semi-structured documents ideal for information exchange, but not for storage. The third type of data I mentioned earlier is unstructured data. This usually refers to free text documents and pictures, for example. How can we store these different types of data? Before I get to that, let me talk about two related concepts. The first one is schema-on-write, and the second one is schema-on-read. Schema-on-write is something that has been used in repositories such as relational databases for decades. This simply means that you first define the structure of the data in the repository before you write to it. This way, when you want to read it back, the structure is defined and you get the data back in that format. The benefit of schema-on-write is that the data can be processed to fit its data type. In the example above, the types int, timestamp, and double can be stored in binary format. This often results in space savings, but more importantly, it is then more efficient to read it back since no additional transformations need to be performed. The drawback of schema-on-write is that you have to plan the structure of your data before you can store the first record. The other approach is schema-on-read. This basically says that you can store the data any way you want, but you have to figure out what the format is when you read it back. Many people like this approach because of the flexibility it provides. This way, if you have structured data, you can simply store it as comma-separated values with a header that provides values names. If you use semi-structured data, you store it as is in a file. Same thing for unstructured data. Let me be blunt. I think in most cases, using a schema-on-read approach is stupid. Let's start with structured data. In data science, we write a lot of data in our repository. I'd say we read that data a lot more often than we write it. By putting a little thought into it, we can avoid transforming character fields into integers, doubles, timestamp, and so on every time we read them. That is a lot of processing that can be avoided. What about semi-structured data? As we saw in our example earlier, there are a lot of semi-structured documents that have a direct translation into simple records. Keeping them as text documents make them even more inefficient than the comma-separated value files. In some cases, the hierarchical structure of a JSON or XML document does not fit into a simple table structure. The solution is to use multiple tables that connect to each other with a one-to-n relationship to store the information. For unstructured data, we can store it as is and extract some metadata that could be part of the structured data. If we do not use the unstructured data as part of our modeling, we can avoid reading it, improving performance. There is a lot more to know about data storage. This is where data science projects can benefit from having team members that have database management experience, for example. See you next time on Bite-sized Data Science, and don't forget to subscribe.